Okay, so this is going to be our day 5 lesson of Unit 1. And in this lesson, we're talking about the 2D Cartesian coordinate plane, so just getting a little bit of an introduction into it. So in it, we're going to talk about, well, what is a linear equation? What do the letters x, y equals mx plus b all represent? So what does that represent? And that should look pretty familiar. A lot of this should look really familiar from Algebra 1. How do we graph linear equations in this form, y equals mx plus b? And how can we use these equations to represent real equations? And last but not least, what's true about parallel linear equations? So let's jump right in here. So the 2D Cartesian coordinate plane. Okay, so we have a conjecture here. If you have two one-dimensional coordinate planes perpendicular to one another, then you have a 2D coordinate plane. Is this true or false? Obviously, it's true. So the x-axis by itself is a one-dimensional coordinate plane, right? It's a number line. And so is our y-axis. And when we put them perpendicular to one another right here at the origin that we call, right, we get a two-dimensional coordinate plane wherein if I've got some point that exists here, I can define it using x and y, horizontal and vertical. Okay, so proof right here in the picture. Okay, so easy peasy, right? So what is a linear equation? Well, a linear equation, to put it simply, is it's a equation in two variables or a function in two variables, and that's getting more algebraic. But it's an equation in two variables that increases at some constant rate of change, right? Increases or decreases, right? It has a constant rate of change, a constant slope. Okay, so what is a linear equation? A linear equation is an equation in two variables in the form y equals mx plus b, and it has a constant slope or rate of change. The rate of change is unchanging, ironically. Okay, so what do the letters in all of this mean? Well, m, we just said, is our slope. Okay, x is our independent variable, and y is our dependent variable. And last but not least, b over here is our y-intercept. Okay, so that answers EQs 1 and 2. It pretty much answers all of these questions on here also. So we answered what does y represent, x, m, and b. Why is it called a linear equation? Well, if it's got a constant slope / rate of change, right? So it stays in a straight line. It continues and continues on its set path, its direction, right? The rate of change remains the same. You still always have the same delta y and delta x. Okay, and we'll talk more in depth what all that means in the next lesson, right? But for right now, so let's look at how we graph these things. So let's graph this first one. So y equals negative 2x plus 1, right? So our y-intercept is plus 1, meaning we're going to start here at y equals 1. And then our slope, m, is equal to delta y over delta x. This is a fancy way of saying the change in y, or the rise, over the change in x, or the run. Okay? So you can think of it, I'm sure a lot of you have heard this coming up through Algebra 1 and pre-algebra when you were in junior high or in 9th grade. Okay? So we're going to start at y equals plus 1, and then our slope here, so in this case, our slope is m equals negative 2. Well, how can I represent it as a ratio of rise to run, right? Of change in y to change in x. Well, I can just say negative 2 over 1, or I can say 2 over negative 1. They both mean negative 2. So what that means is, I'm going to use this one first. My change is down to right 1. So that's minus 2 plus 1, minus 2 plus 1, minus 2 plus 1, right? Or if I follow this line of reasoning, plus 2 minus 1, plus 2 minus 1, and you get the idea, right? And then from there, it's just a matter of putting a line through it. So let me find one. So all I'm going to do, and let me see if I can get this right on the first try. And I hate that it defaults to something so skinny, like really, dude. Yeah. So that looks a little less wimpy, right? So if I run it all the way through, I mean, we clearly see this is our equation, y equals mx plus b. Okay, so pretty straightforward. And I'm going to leave that blue line there so I can use it for these other examples. So this next example, I'm going to do it in blue. Okay, so now I've got y equals negative 2x minus 1. And I'm going to go ahead and just to illustrate something. Let me move that over. But anyway, so I have the same slope again. So my m is negative 2 this time. And it's exactly the same as it was. It can be expressed as negative 2 over 1 or 2 over negative 1. Right? But what's different this time? Well, I have a different y-intercept. I have an intercept of y equals positive 1. Whereas my intercept over here was y equals, whoops, I'm an idiot. I said that backwards. I now have an intercept of negative 1. Right here, I had an intercept of positive 1. Okay? Make the ones fancy. Anyway, so all that means is my slope is going to remain the same. So I'm going to use this one first. So minus 2 plus 1, minus 2 plus 1, minus 2 plus 1. Okay, now I'm going to use this one. Plus 2 minus 1, plus 2 minus 1. You get the idea. Okay, so what I'm going to do now is take this line and line it up here more or less where it should be. Whoa, didn't mean to do that. Okay, and you're going to notice something here. These two equations, so in red, I'm going to call this guy, I'll go ahead and kind of go over it. So in red, I'm going to call this guy the y equals negative 2x plus 1. And in blue, I'm going to call this guy y equals negative 2x minus 1. And there's an obvious thing going on here, but I'm not really going to bother about pointing it out just yet. But if you think about it for a second, what is true about those two lines? Okay, so not going to go into that detail yet. You guys can figure that out for yourselves pretty easily, I'm sure. I'm going to delete one of these. So let's move on to our next example. So number 3 now. And I'll just use red again because why not? So now I've got y equals 1/3 x minus 4. Right? So now my slope is 1/3. And I'm going to express that a different way as negative 1 over negative 3. Negative divided by a negative is a positive. You'll see why that's important here in a second. And then my y-intercept is now negative 4. Okay? So from here, I'm going to count plus 1, plus 3, plus 1, plus 3, plus 1. Well, I'll go ahead and just illustrate. Plus 1, plus 3, plus 1, plus 3. Right? And then I'm going to use this one. Minus 1, minus 3. Had a brain fart. Minus 1, minus 3, minus 1, minus 3. Okay, and then I'm going to go ahead and take this line. And let's line her up. Line her right up. And not quite right. There we are. Okay, so we see something here. So positive slopes tend to increase upwards, right, from left to right, and negative slopes increase downwards from left to right. So nifty trick to remember there. But anyway, this would be y equals 1/3 x minus 4. Okay, and last example, y equals 3/2 x plus 3. Doing that one in blue, apparently. So m is equal to 3 over 2 or negative 3 over negative 2. And that's just for when I count. My y-intercept is positive 3. And that's where I'm going to start from. So plus 3 plus 2. And I ran out of room. Go ahead and use this one. Minus 3 minus 2. Minus 3 minus 2. And just on and on. Okay, so I've got all the points that I need. I can go ahead and line this up. Ooh, whoops. Not what I meant to do. There we go, almost. It's just going to bother me unless I get it perfect. And there you have it. Okay, so you'll be doing this on your graph boards, maybe on a little cutout of paper that you want to glue in your notes. Don't really know yet. We'll see how it goes. Okay, so almost done. So every hour, 2D Tommy, this guy, is a total savage, and he eats 3 live 2-dimensional chickens. Okay? So number one, if he's already eaten 5 chickens today, let's write an equation that gives y the number of chickens he'll eat in x hours. So y is chickens, and x is time, or hours, right? So the number of chickens is equal to 2 chickens, whoops, not 2, what's the matter with me? 3 chickens for every hour. This 3 live chickens per hour, right? 3 chickens every 1 hour. Well, this is our slope. This is our rate of change. This is our change in chickens over our change in hours. Okay, so y equals mx, well, plus v. So what is our y-intercept here? Well, he's already eaten 5 chickens today. So we need to add the 5 that he already ate. There's our y-intercept. Y equals mx plus v. Okay, so our y-intercept obviously is 5, and our slope is 3. Okay, going off our equation, how many chickens will he eat in 12 hours? Well, that's easy. That's just asking us, what is y when x equals 12, right? So chickens is equal to 3 times the number of hours plus the 5 that he already ate today. That's 36 plus 5, which is 41. So 41 chickens is going to be what he's eating. Okay, graph it. Not going to bother about that in this video, and then sketching the graph again. I guess I can do a rudimentary sketch real quick. Just why not? Okay, so x is hours, and y is chickens, right? So we're going to start here at 5 chickens in 0 hours, because he already ate that much, right? And our slope is, figure out which color I want to use. Our slope is 3, so m is 3 chickens every 1 hour, or negative 3 over negative 1. And we're dealing with the real world, so we're going to stay here in quadrant 1. We're not going to worry about going into quadrants 2, 3, and 4. And I'm an idiot and forgot to talk about that. But so this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. It's not new, but, you never know. Children forget, right? Okay, so I'm basically just doing plus 3 over 1. So this is at 1 hour. Plus 3 over 1, plus 3 over 1, plus 3 plus 1. All right, so 2 hours, 3 hours, 3 hours, 4 hours, 5 hours, and so on. Right, so our graph, more or less, is going to look like this. Okay, so whole bunch of review. Okay, so EQ5, now let's talk about what we saw earlier. if two linear equations have the same slope, what is true about the lines as we graph them, right? So let me make this not so giant. Dang it. Oh, the heck with it. I'll make it giant. Okay, so let's say I had y equals, so let's use the example I had before, negative 2x plus 1 and y equals negative 2x minus 1. Well, we can see these two lines, no matter how far we zoom out, they're perfectly parallel. They're never going to intersect, neither one. Okay? And it doesn't matter how drastically I alter the y-intercept. So y equals negative 2x plus, 23. Still parallel. They're all three still parallel because they have the exact same rate of change. Okay? So what this is telling me is, if two linear equations have the same slopes and y-intercepts, they will be parallel on the graph. So this is false. If they have the same slope and the same y-intercept, right, they won't be parallel. They'll be the same equation, right? They'll be the same equation. But if they have the same slope and a different y-intercept, right, like y equals negative 2x plus 1 and y equals negative 2x minus 1, then they will be parallel. They'll never intersect. Okay? All right, so easy peasy. If you have any questions over anything, let me know. Shoot me an email or ask me in class. Otherwise, goodbye.